Okay, so for part A, what we first have to do is draw the body diagram. So first there's the F right here. Then let's imagine there's a incline right here. So it's trying to go up. So then we're gonna make an FK right here, the force of friction. Then perpendicular to it is the Fn, which is trying to make sure it doesn't slide down. Then finally we have the FG, which is gonna be pulling it downwards for the Earth. And then for 1B, we find B, my bad. We're gonna try to find the contact force. So then we say net force Fy is equal to Fn minus Fgy minus F of y. So here in this scenario, we have, so this is gonna be equal to 0, which is equal to Fn minus Fgy minus F of y. So we can set Fn is equal to Fgy plus Fy, which is equal to Fn. And now mg, so Fgy in this case will be mg cos theta plus Fy, which is F sine theta, is equal to F of n. Make this neater, hopefully. Mg cos theta plus F sine theta is equal to Fn. That will be our answer for part B. For part C, what we had to do is find the acceleration of it. So I'm going to write Fx, because it will be on the slope, is equal to the applied force, the horizontal component of the applied force, minus Fk, minus Fgx, because it's trying to slide down and going against this. So we know it's net force is just going to be Max is equal to F cosine theta, which is the applied force, minus Fn times mu in this scenario, and minus Fmg sine theta. Now we isolate for Ax right here. So Ax is equal to F cosine theta minus Fn mu minus mg sine theta all over m. And then we can expand Fn right here to have our Ax be equal to F cos theta minus mg cos theta plus F sine theta, close parentheses, minus mg sine theta. This is all going to be over m. And this will be our Ax. So then for 5D, we're trying to find applied force we could use. So in this case, I'm just going to write out net force of x equals Fx minus Fk minus Fg of x. I'm just going to leave this as Max for later. And then we could say it's F cos theta minus, we know Fn is just mg cos theta plus F sine theta minus mg cos theta plus F sine theta times mu minus mg sine theta. Next up, I'm going to move anything doesn't have an F in it to the horizontal applied force. So I'm going to move this mg sine theta over to here. So we have Max plus mg sine theta. Then I move this here. So this is mu times mg cos. So it'll be plus mu mg cos theta, which is equal to F cos theta minus F sine theta. Here, I can factor out a F from the right side over here. So Max plus mg sine theta plus mu times mg cos theta. This is equal to F times cos theta minus sine of theta. Then we can isolate for F by dividing by cos theta minus sine theta. And so our final answer, almost final answer, we Max plus, I messed this one up, it should be a plus sign, plus mg sine theta plus mu mg cos theta all over cos theta minus sine theta, which is equal to F. But we're asking, this will be our general form when we're trying to find F. But then it's asking if if acceleration is 0, so I'm going to constant velocity. So then I could put this as 0 right here, so this cancels out. So now we have mg sine theta plus mu g cos theta over cosine theta minus sine theta. And this will be our f for the scenario when acceleration is equal to 0. Okay, so for the second part of 5t, so we look at this denominator right here. So cosine theta minus mu sine theta. Now to make this the fraction actually work, the denominator can't be equal to 0. So now if it's to make not equal to 0, this cosine theta has to be greater than mu sine theta, or else it has to be greater than mu sine theta, because if it's equal to 0, then it's gonna mess it up, and it's probably gonna go the other way. So cosine theta has to be greater than mu sine theta, and I say for mu here, if we divide by sine, we just get cotan theta is greater than mu. And that is for the second part of 5D. Okay, so for part E, we're trying to find the f given the values we were given. So I derived in the previous part, I derived f is equal to max plus mg sine theta plus mg cos mu cos theta. I'll fix this mu. Cos theta all over cosine theta minus mu sine theta. So now we're given an m. So in the previous one, we canceled this one right here because ax was 0. Now we have an acceleration, so we could plug everything in. So f in this scenario is equal to mass is 2 kilograms times the acceleration is 0.5 plus 2 kilograms times 9.8 sine of 20 in this scenario plus mu times 2 times 9.8 times the mu of 0.33 cos 20. This is all over cosine 20 minus 0.33 sine 20. If you plug everything to your calculator, the value should be 16.67 newtons applied onto the block. And then for 5F, now there's an additional block that weighs 4m. So in this scenario, what we can do is since we have 2 blocks pushing on each other, connected to each other, pushing on each other, what we can do is we could combine the masses of the 2 blocks and plug into this formula right here. So if we have, with this formula, we know F is equal to max plus mg sine theta plus mg mu cos theta over cos theta minus mu sine theta. Now, since we're combining these 2 blocks together, this m, instead of being just m, we're going to replace it with 5m, because 4 plus 1 is 5. So instead of m, we have 5m multiplied by ax plus 5m times g sine of theta plus 5m g mu cosine theta. And then it's all over cosine theta minus mu sine theta. In this scenario, since ax is going to be 0 because it's going to be motionless again, this cancels out. So now we're just left with 5mg sine theta plus 5mg mu cos theta over cos theta minus mu sine theta. And this will be our f. We're using a formula for a block of mass 4m and a block of m pushing on each other. So now we're looking at part G. So we know f is equal to 5max plus 5mg sine theta plus 5m mu g cosine theta. This is all over cosine theta minus mu sine theta. So now we can just plug in the values we have. So f here is going to be equal to the mass, so 5 times m, which is 2, m is equal to 2, ax is 0.5, plus 5 times 2 times 9.8 sine of 20, plus 5 times 2 times 0.33, 9.8 cosine of 20. It's a lot of work. Over cosine 20 minus 0.33 sine 20. If you plug in that in your calculator, the answer should come out to be about 83.3 newtons. For 5H, we are going to write net force of F4m of x is equal to F of m on 4m minus F of 4m of gx of F4m minus Fk of 4m. So, over here we can simplify this, expand this to 4m times ax, which is equal to Fm of 4m minus F4 gx of 4m minus Fk of 4m. We can move all this to the left, this F4m of gx, F4mk, so we have 4m ax plus F4m gx of F4m plus the Fk of F4m, my bad, is equal to Fm 4m. We can expand this to 4m ax plus 4m g sine of theta plus 4m g mu cos of theta, which is the Fm of 4m. And then we can just plug our numbers in. So 4 times 2 times our acceleration of 0.5 plus 4 times 2 times 9.8 sine of 20 plus 4 times 2 times 9.8 times 0.33 cos 20, which is equal to Fm on 4m. If you simplify that, Fm of 4m is equal to 55.13 newtons. And finally, for 5I, so I'm gonna write net force of the 2m block on top. That's so F of 2m, which is equal to the 2m g mu s cos theta minus 2mg sine of theta. Now we're trying to find, in this scenario, mu. I can expand this one right here to 2m ax equals 2m g mu s cos theta minus 2mg sine theta. I can move this to the left, so it's 2m ax plus 2mg sine theta is equal to 2mg mu s cos theta. I could divide this by both sides by 2mg cos theta. So now you have 2m ax plus 2mg sine of theta over 2mg mu s cos, oh, not mu, my bad. Mu should be on the other side. So it's just 2mg cos theta on the denominator is equal to mu of s. Then we just plug numbers in. So 2 times our mass of 2 times the acceleration of 0.3 plus 2 times the mass, which is 2 times 9.8 sine of 20, all over 2 times 2 times 9.8 cosine 20 to mu s, which in this case is going to be equal to 0.40. And that will be our coefficient of friction to keep it on, which will be our minimum in this scenario.